Hello everyone, welcome to Brain Blitz Audios. Today in this episode of NEET preparation, we'll be looking at previous year questions of physics in medical entrance examinations in India. Today we're dealing with the chapter Motion in a Plane. This is the third chapter in the grade 11 syllabus for physics in CBSE. Now let's look at our first question. For a particle in a uniformly accelerated circular motion, velocity is radial and acceleration has both radial and transverse components. Velocity is transverse and acceleration has both radial and transverse components. Velocity is radial and acceleration is transverse only. Velocity is transverse and acceleration is radial only. So, which of these is the correct option? If you look at a uniformly accelerated circular motion, you notice right away that the direction changes with respect to time. So therefore, there is always a change in velocity. Because of the change in direction, velocity always changes. And acceleration has two components. Component that goes tangentially, which is called tangential acceleration, and another component that goes radially, so it's radial acceleration. So therefore, option B, velocity is transverse and acceleration has both radial and transverse components, is the right answer. Here, transverse refers to tangential. In option A, it says that velocity is radial, which is incorrect. In option C, again, velocity is radial, so it's incorrect. Both C and D are incorrect because they say that acceleration is limited to one direction only, whereas there are two components for acceleration, one radial and the other transverse. Let's look at this question. For a given angle of the projectile, if the initial velocity is doubled, the range of the projectile becomes half, 1/4, 2 times, 4 times. So here we use the formula R equals U square sine 2 theta divided by G. So if U is doubled, so say we have 2U instead of U, so R dash will become 2U whole square times sine 2 theta divided by G. That is equal to 4U square sine 2 theta divided by G. U square sine 2 theta by G is the original range, so R dash will be equal to 4R. So the range of the projectile multiplies by 4 times, so it increases 4 times as much. So option D, 4 times, is the right answer. And again, we use the formula R equals U square sine 2 theta divided by G in order to prove it. Next question. If we can throw a ball up to a maximum height h, the maximum horizontal distance to which we can throw it is. So we need to find the maximum horizontal distance R max with respect to maximum height h. So the usual formula for h is U square sine square theta divided by 2g. However, since sine square theta becomes 1 because the height is maximum, so it will be equal to U square by 2g. Therefore, you can write U square as 2gh. The reason why we do that, let's find out when we calculate maximum range. So R is equal to U square sine 2 theta divided by G. So when R is maximum, sine 2 theta is 1. So U square by G is the value of R. Let's put the value of U square as 2gh, and then the denominator is h. Both the g's gets cancelled, so R is equal to 2h. So therefore, option A, 2h, is the right answer. And we use both formulae for maximum range and the formula for maximum height for a projectile in order to find out the relation between maximum height and maximum horizontal distance. So if you can throw something high, say h meters, then you can throw it 2 times as far. Let's look at this question. The vector sum of two forces is perpendicular to their vector differences. In that case, the forces A cannot be predicted, B are equal to each other, C are equal to each other in magnitude, D are not equal to each other in magnitude. So let's consider the two forces as A and B, vector A and vector B, say. So the vector sum can be written down as vector A plus vector B, and the vector difference can be written down as vector A minus vector B. Now, here it is said that the sum and the difference are perpendicular to each other. So that means vector A plus vector B dot product with vector A minus vector B will be equal to 0. The dot product of two perpendicular vectors is 0. So A plus B times A minus B will give you A square minus B square equals 0. So that means A square will be equal to B square, taking square root on both sides. Modulus of A is equal to modulus of B. So both their magnitudes are equal. So option C, are equal to each other in magnitude, is the right answer. So the reason why option B is incorrect is because the direction may differ. Even if the direction may differ, this condition, that is the equality in magnitude, holds. So therefore option B cannot be correct, but C can. They can be equal to each other in magnitude and still face in different directions. So since we've predicted this, option A cannot be predicted is incorrect. And since we found them to be equal, option D is also incorrect. Let's look at the final question for this episode. A projectile can have the same range for two angles of projection. If h1 and h2 are the maximum heights, and the range is r, then you need to find the relation between r, h1, and h2. So the question's condition is same range for two angles of projection. So that means the angles will be complementary. So same range will apply for complementary angles. So therefore, two angles which are complementary will have the same range. So let's find out the values of h1 and h2. So here we use the formula for maximum height, not for maximum height, we use the formula for height of motion, which is u square sine square theta divided by 2g. And for h2, since it's complementaries, it'll be u square sine square of 90 minus theta divided by 2g. 90 minus theta, sine of 90 minus theta is cos theta, so it will be u square cos square theta divided by 2g. So now we know the values of h1 and h2. Let's write down the product. h1 times h2 will be equal to u square sine square theta by 2g into u square cos square theta divided by 2g. That will be equal to u raised to 4 sine square theta cos square theta divided by 4g square. Now, remember that we often use the formula sine 2 theta is equal to 2 sine theta cos theta. If we square this on both sides, then you'll get sine square 2 theta will be equal to 4 sine square theta cos square theta. So over here, you notice that you have sine square theta and cos square theta, which are multiplied to each other. So what you can do is you can multiply and divide by 4. So we will multiply and divide by 4. So therefore h1, h2 will be equal to u raised to 4 times 4 sine square theta cos square theta divided by 4 times 4g square. So therefore it'll be u raised to 4 sine square 2 theta divided by 16g square. So u square sine square 2 theta can be written down as u raised to 4 sine square 2 theta can be written down as u square times sine 2 theta the whole square. And you can also write 16 times g square. Now the reason why we're converting it like this is because of the formula for range. The formula for range is u square sine 2 theta divided by g. The formula for r square will now become u raised to 4, or instead of u raised to 4, let's just write u square sine 2 theta whole square divided by g square. So now we write the product of h1 and h2 in terms of r. So h1 into h2 is equal to r squared divided by 16. So therefore you get r squared equals 16 h1 h2. Taking the square root on both sides, you get r equals 4 times the root of h1 h2. And if you look at our options, you see that option A, r equals 4 times root of h1 h2, is the right answer. So therefore, by using the formula for height and the formula for range, and taking the condition that two angles are complementary when they have the same range, you can find out the relation between r and the two heights, h1 and h2. So therefore, option A is the right option. That concludes this episode of NEET preparation. For getting more videos on this chapter, don't forget to click the link in the description down below. For more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. So until the next webisode, take care, stay safe, bye-bye for now.